Hi everyone, welcome to Tuesday's science lesson. Your learning objective: identify changes that can be reversible and irreversible. So your first question, what does reversible and irreversible mean? Pause the video and write down your thoughts. Let's see if you were correct. So chemical changes come in two important types: reversible changes and irreversible changes. Reversible changes is when materials can be changed back to how they were before the reaction took place. So for example, when ice melts to form water, it could be frozen back to ice again. Irreversible changes are when materials cannot be changed back to how they were before. So if a piece of wood was burned to form ash, it would not be able to make wood again. Now, there are two links here, just giving you two very short explanations of reversible and irreversible changes. So pause the video and click on those two links. Right, this is your task for today, and we are doing this slightly differently today. You're going to pause the video in a second and go and complete the activity and then come back to the video again afterwards. And there's a reason for that, because we are asking you to predict. And obviously, if we've given you all of the information, then you won't need to predict because you'll know the answers. So have a look at the liquids and foods in these pictures. Use the table, and the table is here, to predict whether any of the changes occurring due to heating are reversible or irreversible. It says test your predictions where possible to find out whether or not your predictions were accurate. So you've got these pictures here. You can add to that as well if you want to. So if you haven't got access to these items, these foods and liquids, but you have access to others, then of course just choose those instead. Now you write, or you can just print the page here. You've got your food and liquid down the left hand side, and obviously if you're doing different foods or liquids, you can add to this list. You write your prediction in here, whether you think it's reversible or irreversible. If you're able to test your theory, you put your result in here, and then you say whether your prediction was accurate at the end. Okay, so pause the video and go and have fun with this activity. Right, I hope you had fun with that. I just want to give you a little bit of extra information now. So you'll be really familiar with this diagram that you can see. It says changing state from solid to liquid to gas and back again is a reversible change. So if we take the example of the ice lolly again, it would start as a solid and then obviously become a liquid. And you can see exactly how that process would work for each of those changing states. And again here, all changes of state are reversible, and that includes melting, boiling, evaporating, condensing, and freezing. And again, this diagram we looked at in week 3. So if we take our example of the ice lolly again, it would start as a solid. When it melts, it would become a liquid. It could then evaporate to become a gas, condense to become a liquid, freeze, and become a solid again. It does say, do you know what all of these words mean? So you can pause the video here if you're unsure, and you can look up a definition of them. Right, here's some examples now of some reversible changes. So mixing and dissolving are reversible changes. So if you have a look at the image, you've got the sugar being dissolved into the tea. You can get the sugar back again by evaporation. Mixing salt and sand, you can separate them by sieving. And here's a few explanations for you. So if you're still unsure, separating mixtures can be done by sieving, which is when two solids are mixed. Filtration, when a solid and a liquid are mixed. Evaporation, when a solid is dissolved in a liquid. Some examples of irreversible changes. So it says cooking, making a loaf of bread. The flour, yeast, oil, water, and salt are all mixed together and then heated in the oven. They react together in a way that means you can't unmake the loaf again afterwards. All cooking is like this. Burning. When green grass, when green grass burns into black ash, it is impossible to get the green grass back again. A chemical reaction where substances react together to form new substances. So rusting, for example, Iron and oxygen equal iron oxide. So together, that's what they equal, iron oxide. It's impossible to get the unused iron back again. So that would make it irreversible. And now finally, we're just going to go through your table to see how you got on. So hopefully your predictions, even if your predictions weren't correct, you were able to carry out that activity and see what the correct result would be at the end. So let's go through them together. So melting an ice lolly would be reversible. Burning wood would be irreversible. So when you burn the wood, you get ash and smoke. You would not be able to turn the ash and smoke back to wood again. Cooking an egg is irreversible. The cooked egg cannot be turned back into a raw one. Melting ice cream is reversible. Boiling water, also reversible. Warming chocolate, reversible because you can leave it to cool. Now, melting butter on toast. Now, this one is slightly tricky because melting butter is reversible. However, when it's mixed on the toast, unless it seeps through, that is going to be irreversible. Cooking meat, that would be irreversible. Baking a potato, again, cooking, so irreversible. Melting toffee would be reversible. So I hope you got all of those correct, and I hope you had fun with that activity. I'm sure I'll see you on the screen again tomorrow. Take care, and I look forward to seeing you soon. Bye.